So there were some very important words used when we were in the headcount analysis phase, and that was if we are efficient. There's no point saying that you can do it with 17 heads if then you have inefficient territory and route optimization processes. So let's have a look at the territory optimization process and how we can make that efficient and streamlined. So what we're looking at is the existing territory structure for this northeast area. And obviously each of the colours of territory, what we can see is some kind of polygons or bound bricks that we're using to create the territories. In this example, it's zip codes. So what we're having in the system here is we've got obviously the yellow squares, which is where the people live. What we can also see is some information about the territory. And if we just focus in on one of the metrics here, this blue label is saying, well, the current territory structure, Stephen, is nearly 28% underworked. So Stephen's effectively being paid for a full-time territory, but only busy for under 4 days a week. Conversely, in the orange territory, Sam is nearly 30% overworked. So she's trying desperately to squeeze all these calls into a day. She's either missing calls, doing very skimpy calls, working very long hours, maybe a very real content to leave the business for a better work-life balance. Now you might say, well, how have we ended up in this situation with one being significantly under, one significantly over? Well, that is because it is important when balancing territories to think about what needs to be balanced and what is realistic and what reflects the working day. And the reality is that what we want to do is balance on time spent in store, but also reflect the amount of driving in each territory. What people often do is they will do the former, so they'll give each territory, say, 200 calls or 200 stores or something like that, and assume that is a balanced territory. But when you add on top of that, maybe that one of those territories is metropolitan and very well connected, and another one is rural and a very poor road network, you can suddenly see how what once appeared balanced is actually in reality, when you think about the reps working day and how they do in-store work, then they drive, then do in-store work, that is going to be very, very imbalanced. And so we see these kind of imbalances all the time. And as we said before, under or over neither is really good for the business. One could do more work, the other is probably not doing particularly good work and may well require replacing, have a fallow territory, all those kind of things. So how do we put this right? Well, you could do it manually, so you could move some of the orange territory into blue, but again, where are you going to take the work from? There are a number of options. So again, it'd be very subjective, and again, very time consuming. And because you can probably only use the road network at a very high superficial levels, it's really not going to be efficient and utilising those travel times the best way. So we would advocate doing it through optimisation. And what we're talking about here is clicking on an optimise button and getting an algorithm to do the work for you. So this is moving, in this case, zip codes between territories. It's doing so to achieve balance of workload, including that important driving. It's using a road network to choose which zip code should be moved, which ones are really easily accessible and sort of hang together sensibly. And it's also doing things like identifying where to recruit for vacancies. So again, it's one of those things, one of those stats that we found over the years. If you can recruit someone in the right location, they're likely to spend around 43% less time driving in the commuting period, those sort of bookends of the day, which will really impact on the quality of their work-life balance. So that is a really good thing to have. What you'll see, obviously, is this is very quick to do. This has done the optimization of that northeast region. So again, rather than doing it very slowly and laborious, what we can now do is go and see our new proposed map. And not surprisingly, Stephen has bled over the border a bit, and you'll see actually he's taken a slice right across the orange territory, such that Stephen is now beautifully balanced, as is Sam. So both of these people, despite having very different, probably road network profiles in their territory, are working, starting and finishing very similar times. You can manually override, so you can then say, well, actually, I want to move a couple of bricks because of particular reasons, but at least you'll be starting from an efficient position. I mentioned before about ideal locations. These black and white bullseyes are the ideal locations. So if Sam were to leave, we'd recruit someone up here. And again, that would very much improve the travelling profile of the territory. And as you see, it's very quick to do. So you can do lots of different types of scenarios. So we do fixed reorganisations, which are built around where people live. We have floating reorganisations, which ignore where people live and say, if I were to start again and be able to recruit, where would I go? And then you've got everywhere in between. So if you have a couple of vacancies, you can really try and use that to have a real quantum leap in efficiency by getting those people in the right places rather than just replacing where you've lost people. And the output of this is you know who owns which zip code or postcode or census area, you know who owns which stores, and then you can obviously create maps and Excel reports and spreadsheets out of that and disseminate those out into the field. But that is territory optimization.